Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. My dear student, in today's lecture, we will explore a very important type of chemical bonds that gives metals their unique properties, which is metallic bond. So sit tight and listen carefully because by the end of this class, you will understand why metals are shiny, conduct electricity, and can be shaped into wires and sheets. So, metallic bond, my dear student, a metallic bond is the type of chemical bond that holds metal atoms together in a metallic crystal. My dear student, it is formed by the electrostatic attraction between the positively charged metal ions and the sea of delocalized electrons surrounding them. My dear student, and metals, the valence electrons are not bound to any particular atom. Instead, they are free to move throughout the crystal lattice. Explanation of metallic bond. My dear student, each metal atom loses its outermost electrons, becoming a positive ion mean cation. The last electrons become delocalized, moving freely through the entire metallic structure. These delocalized electrons act as a glue holding the cations together by electrostatic attraction. This result in the metallic bond. Now, a presentation of metallic bond. My dear student, metallic bonds are usually represented as positive metal ions plus C of delocalized electrons. Example, sodium lost electrons and these electrons are delocalized. Now, my dear student, characteristics of metallic bond. Electrical conductivity. My dear student, delocalized electrons can carry current. Thermal conductivity. Electron transfer heat energy quickly. Malleability. Metal atoms can slide over each other without breaking the bond. Ductility can be drawn into wires. Luster. Free electrons reflect light, giving metals a shiny appearance. High melting and boiling points. Strong metallic bonds require much energy to break. Now, examples of metallic bond sodium metal. But a student, sodium atom loses one electrons, forming sodium positive mean cation. Electrons become delocalized and move freely through the metal lattice. Sodium ions are arranged in a regular crystal structure and held together by the sea of electrons. And the second one is magnesium metals. Magnesium atom loses two electrons, forming magnesium ion. Sea of electrons surrounds magnesium ions. A strong attraction between magnesium ion and delocalized electrons results in stronger metallic bonds than sodium. Now, key points are to remember. Metallic bonds are non-directional, mean have same strength in all direction. Strength depends on number of delocalized electrons per atom, charge of metal cations, and size of metal atoms. What is student this is all about? metallic bonds. I hope you understand. But dear student, if this lecture helped you, then don't forget to like the video, subscribe to the channel for more class lecture, and also share it with your friends and comments your question below. Take care and see you in the next class. Thank you for listening.